Okay, we're going to now man an assembly plant. So the question is, how would you go about doing that? So we're kind of going to walk through at a high level of how we would do that. So we have a new product launch. Let's assume that this is a brand new built plant. So what should our target be for manpower? That's a good question. And how would we do that? So remember this, tack time, level, rate at which the customer pulls production to the plant, the metronome. That's where we begin, because we have to know, what does the customer want per year? What are we forecasting? Typically over the life of the product. Usually a new model launch lasts 3 years before it's either updated or completely replaced. So we have a new product, and we're forecasting over the next 3 years a leveled demand, meaning that once we set this plan up, we do not want to change the line speed, if at all possible, because it's just a nightmare to change line speed. So we manipulate that level balance schedule by incentives to the customer and rebates, shutting down the plant for several weeks, working Saturdays, possibly even going to third shift. So we have a lot of different ways in which we can maintain that line speed. But we make as accurate a forecast as we can about what the customer is going to want over the next 3 years for this product that we're launching, so that we can set this whole facility up based upon that and then not change it. Because the car is on a moving chain. It's not like a work cell where you have flexibility to volume. The volume flexibility is not easy. It's not something that you can just adjust day to day or week to week. So we start out with this tack rate that we predict. And of course, that defines perfect balance and even flow of products. Tack time minutes of work per day, units desired by the customer per day. So we're going to say we're going to work 912 minutes a day. We're going to say it's a 2-shift operation. So that's typically what they'll set a plan up. Obviously, they want to utilize this space and use 2 shifts to run it. They've got a third shift if they need it. And they can retract to a first shift. So does that make sense? I'm setting up right in the middle of my capability. I have room to move one direction or the other, worst case. So we're going to say the units desired per year are 200,000. There's 250 work days. 800 units a day are what we're going to produce. That's based on our market research. This is a car we're building. We believe that we can support this kind of volume. So in this case, our tack time is 68.4 seconds, which is the rate at which customers put in cars on the truck. Is that the rate we're going to run the line? Are we going to run the speed of the line? Remember, this is a unique situation. That's why I want to talk about assembly plants, because the work isn't paced by people. It's paced by a chain pulling the car through at a steady rate. So do we want the chain to be pulling the car through the assembly plant at 68.4 seconds? No. And why?
Need to plan for some things to go wrong.
Yeah, and I think for the sake of understanding, we're going to call that OEE, because typically that's what drives it all. So OEE, we've got to account for what is the difference between perfection, which is setting this plan up at 68.4 seconds, and problems, things that go wrong, which we're just going to call OEE for the sake of argument. Could be other things, but it's typically based around that. So if we were on a 1-shift operation, we'd have to run a speed of 34.2 seconds. That'd take a lot more people, right? A lot more processes. You don't have as much time to put the car together, so you're going to have double the manpower, double the processes. So what should the cycle time or line speed be? There's the, let me go back one too quick. Cycle time equals tack time minus allowance. We're going to say it's OEE. Allowance is overspeed. Overspeed is waste. So obviously, if you want to reduce waste, you slow down, right? Rebalance. So what is Taiichi Ohno's #1 waste of the 7? Overproduction. Drives everything. So this is just a review here. Availability, 800 divided by 912 minutes. We're going to say 87.7. Performance, 93.8. Quality, 95.2. Overall equipment effectiveness, in our case, is 78.4. We're going to say that's our capability. So the benchmark OE for industry average, because we should always be looking at the benchmark, right? We're a competitive business. We live and die by being competitive. If we don't task ourselves to be competitive, we could disappear. So if the benchmark for the industry is 80.4, planned OE improvement to meet industry average of 2%, so we need 19.6% overspeed. 19.6% is waste, right? Just pure waste. We've acknowledged it. We know that we're not perfect. We know that we have to build in this amount of waste in our assembly plant. So you see how vitally important it is, OEE, driving that metric. So 80.4 of 68.5 is 55 seconds, so we're going to set our line speed at 55 seconds in this example. So now what? So now what are our targets for the processes? How many processes should we have? Should we have the number of processes that the car dictates, or should we task ourselves to do something different? We're a competitive company, right? Can we just do whatever we need? Can we just set our plan up however we like? This car's kind of complicated. Looks like we're going to need this many processes to be able to build it. But you got to pay for that. And typically you pay more for that than you do it yourself. And we talked about that last time. So why would we outsource if we're better than the outsourcing company?
Because economies of scale, maybe that companies are.
That's a good point. That's possible, yes. Well, you can't outsource putting the car together, though. You can outsource components, but that's a good strategy because you might say, how do we get the number down? How do we be competitive? Of course, when you look at the number of what other companies are producing at, you got to understand what they've outsourced, right? So if you find out, oh, they can build a car with this many processes, now you have to go through the analysis and say, wow, half of the things that they put in the car are outsourced. You have to factor that in because there's a cost related to it. So direct labor manpower targets. So benchmark, 18.5 hours of direct labor to build one unit. So what is that benchmark? If you recall, remember we talked about the Harbor Report? Harbor Report is an industry standard where they measure every vehicle built in every place in every country. And they tell you, here is what it takes to build a Nissan Sentra, 18.5 hours of direct labor. So since you know what that number is, the benchmark for the same assembly plant is what you want to target, and we say that the benchmark for that assembly plant is 18.5 hours, meaning we're going to build this vehicle, and this car that is very, very similar in size and shape and content is 18.5 hours. So we know that it doesn't matter how much it takes to build this car. What really matters is, can we even stay in business? So we have got to target manpower based upon a competitive number that our competition is building this car at. That's going to dictate how many processes we have, not what it takes. So do you think it's important when we design the vehicle that we think about these things? See how critical the design of the vehicle is? Because you know when this thing hits the floor, when you throw it over the wall and say, now build it, you've got to have a product that's designed in such a way that you can be competitive on your labor, or you're not going to make it. So it's 18.5 hours to build one unit. And then what should we do? Should we task that a little bit? This is what management people do. They say, okay, if the best is 18.5, and this is a brand new plant. It's a brand new plant. We're taking a second shot at this. They've already put that in place, and that's their current manpower. We kind of think that we should be able to improve upon the benchmark a bit. So we're going to give you a task. So you're the industrial engineers for building this new plant. So we're going to give you a task. We're going to say, you've got to build this car with 18 hours of direct labor so that we can be competitive. So we'll say the first 3 rows are assembly. We'll say the next 2 rows are paint, and the last 2 rows are body. And this is the team, and this is your job. So how much labor do you get for assembly? Meaning how many processes do you have to set up? So at 18 hours, there's the seconds, 400 units per shift is 18 hours, okay, 900 people per shift, 900 direct labor processes. Do we need 1,800 for 2 shifts? No, because we're defining processes. People just come in and they get on the process on the next shift. So we need 900 direct labor processes in that plant, actual workstations that do something for us to be competitive. That's our target. So how many do you get, assembly? This is your task. So this is a typical ratio. So we're going to tell assembly, you get 612 processes. Maybe we should go back 3 rows, maybe 4 rows. Yeah, we'll go 4 rows. 4 rows is assembly. 1 row paint, 1 row body. Paint shop gets 108. Body shop gets 108, and paint shop gets 180. So now you have a task the first 4 rows. You have 612 direct labor processes that you've got to set up and define per the engineering requirements and standards. Setting up the proper sequence and all the requirements, and defining all the work. So there's a launch team typically. Typically, this is how a launch team is made up. You have design engineering. Of course, we just mentioned they have a significant impact on hours per vehicle. And this starts about 3 years, 4 years prior to the car actually going into production. So they're developing design early on. You have production control. These are the material and logistics people. You have salary and hourly teams from body paint and assembly that work process that have been, we pick out some of the better people we have in those organizations and we send them off to the launch team to work with the engineering group 3 years prior to launch. And then design and process requirements are defined and manpower targets are defined that we just did. So you got this complete launch team, and you're the industrial engineering piece of that.